Speaking of the heat and emotion around the K2 issue, it seems like if I've heard it once, I've heard it 1,000 times. That K2 helps vitamin D3 and the body in general deposit calcium in the bone and take it out of arteries. But didn't you ever wonder, well, how does it do that? And maybe it wasn't 1,000 times, it just feels like it. But surely dozens of times. Again, so much focus on what that supplement does, but not really that much focus on how is it supposed to do that. And again, this is, we'll just mention a couple of quick scientific articles, but the key part of this video is to get a little bit deeper on the mechanism for vitamin K2. How it can have such an impact in two areas. Yes, there's research out there. This is from a respected journal. I've reported on it a couple of times. Vascular calcification involved with a thing called matrix GLA protein. Well, I'm not going to get into gamma carboxylation and all of that business, although that is a part of this issue. Here's another randomized clinical trial, which is, again, pardon the bad graphics here. Here's the bottom line. There's not a lot of randomized clinical trials which are good, they're large, they're publication worthy, and they show decreased plaque in arteries is associated from vitamin K2. And pardon all that stuttering around. I'm trying to find my words and be accurate. I just need to move on, right? This starts to get a little bit more clear on the process and the mechanism. You remember I mentioned matrix GLA protein? That's what this is, matrix GLA protein. Well, what it does is it does help pull calcium out of the walls of soft tissue. But guess what? It doesn't do that unless it's carboxylated. That's where this carboxylation discussion comes into. But again, we won't get too deep. Don't worry about that. The carboxylation requires K2. So K2 is required to get this MGP, matrix GLA protein, activated so it can start pulling calcium out of the arteries. So that's one part of what you continually hear about pulling calcium out of the arteries. And there's good research around that. Again, that was one of the articles around it, but there's a lot of others. But what about the other side? So that's vascular calcification and inhibiting calcium in the vessels. What about increasing calcification in the bones? Same thing. There's another protein analogous to matrix GLA protein. It's called osteocalcin. And the same thing happens with osteocalcin. It's inactive in the uncarboxylated form. It has to be carboxylated in order to work well. Let's get a little bit deeper in terms of osteocalcin. And K2, MK7. There's a thing called osteoclasts and osteoblasts. These are two types of cells which control bone growth and bone density and deposition of calcium in the bone. Remember, osteoblasts deposit bone and protein and grow the bone. Osteoclasts take the bone up. Now, how am I going to remember that? Back in med school, simple thing. There's a B in osteoblast, build, B for build, and a C in osteoclast, C for cut. So maybe that can help you remember the difference between those two. What's interesting is, even within the bones, MK2 is used in both of these processes as well, pulling calcification out of the bone and in putting calcification in the bone. Now, let's go back up. Remember we talked about carboxylation? This is a diagram around the carboxylation. This comes from that Journal of the American College of Cardiology article. And it's talking about the matrix GLA protein. If it's non-carboxylated, it doesn't function that well. It has to be carboxylated. As you might have guessed, there's an enzyme called gamma carboxylase. Actually, let's leave that alone. After it's carboxylated, then it becomes active and can start helping remove calcium from the artery wall. Vitamin K antagonists like warfarin are known to greatly increase calcification of the artery walls. What has that got to do with anything? Again, I covered that in another area, but warfarin actually appears to inhibit gamma carboxylation as well as vitamin K1 activities. So again, maybe getting too far into too many dots. Let's go back out and just repeat something to help simplify this. Vitamin K2 does have a role in increasing calcium in the bone and in decreasing calcium in the vessel walls. As you see here, it also has a role in decreasing bone. So, how does it do it? It's part of a thing called a carboxylation process. And I'll get deeper into that. One of the reasons that carboxylation process is very important is it right now is the only lab test that we have that can actually look a little bit deeper into measuring these activities. We don't have great vitamin K2 function tests. And as I've said before, the state of the art is still inconclusive regarding vitamin K2. I'm beginning to see that there's enough information out there for me to where I am focusing more on it, as you can tell. I've committed a few times to doing a series on K2, and that's what I'm doing. How about osteocalcin and MGP, matrix GLA protein? Are they something that is just theoretical? No, they're not theoretical at all. Just go to Wikipedia. You'll see this picture in Wikipedia. It's the actual protein orientation and structure for osteocalcin, which is involved in laying calcium down in the bone. And here's actually the protein, the amino acid structure. Some photomicrograph images of matrix GLA protein and some other information about it. These proteins are very well known. So again, I hope this helped continue to just push that awareness just a little bit further regarding a very interesting backstory on K2. Thanks for your interest.
Di BINARAGA.NET, kami selalu percaya bahwa setiap orang pasti bisa memiliki tubuh yang ideal dan sehat. Dengan subscribe, like, dan share video ini, Anda turut membantu membangun Indonesia sehat dan kuat. Salam jelas fitness, saya JP.